You got it? No. It really doesn't take this long.
Hello, this is Garrett, and this is
Brooke.
And we are here today to show you an introduction to Lewis dot diagrams.
What the heck is happening?
It's one button, Brooke.
Go.
Are you going?
Yeah.
Okay. In covalent bonds, it is a sharing of electrons between two atoms or more. The first type of covalent bond is a single bond, and that is the sharing of two valence electrons between two different atoms. And that is one electron from each. And the next type is a double bond, and that is sharing four valence electrons, and that's two from each atom. And the next type is the triple bond, and that's a sharing of six valence electrons altogether, and that's three from each atom. And then there is the coordinate covalent bonds, and both valence electrons come from a single atom.
What? Did you have to go or not? I'm so confused.
It actually means zero.
Oh, okay. The octet rule is where all atoms want 8 valence electrons, except for hydrogen and boron. That's it.
Alright. To first make a Lewis dot diagram, you need to have a periodic table so you can determine how many valence electrons an atom has. And the nitrogen trifluorine compound, nitrogen is electronegative, and it has a valence electron shell of 5 electrons, while fluorine has 7 in its valence shell. And there are 3 fluorine atoms, so you have to multiply 7 valence electrons by 3 atoms, and that gives you 21 electrons. Then you have to add that to the 5 electrons that nitrogen gives you, and that gives you a total of 26 electrons. And Brooke will demonstrate what a nitrogen trifluorine compound looks like in a Lewis dot diagram. And remember that each of these lines represents a single bond, and that is the sharing of 2 electrons each. So that means that they are each sharing 2. And yeah, we'll draw the dots.
Okay. Okay.
And since you have 6 electrons that are bonded in the single bonds, you can subtract those from the 26 electrons that you originally had, so you have 20 left, and that's what the dots are represented by on the outside. And so you now have 8 in each valence shell, with the 2 represented by the lines. And that is how you draw a simple Lewis dot diagram. Action. Alright. This is another example of a Lewis dot structure, and this is using the compound CS2, and the most electronegative atom in this compound is carbon. And carbon has a valence electron shell of 4 electrons, while sulfur has 6, and since there are 2 atoms of sulfur, you multiply the 6 electrons by 2, and that gives you 12 electrons. So once you add the sulfur and the carbon together, you altogether have 16 electrons. And you may think that this looks okay with the carbon sharing with 2 single bonds, but you may notice that the sulfur is happy and it has 8 electrons in its shell, but the carbon only has 4 since it's sharing 2. And so instead of just using single bonds to satisfy all the atoms, you'll have to replace 2 of the electrons on the sulfur atom and add double bonds. So now each one is sharing 4. And so you have 4 electrons being shared between each compound, and so that gives carbon a total of 8 electrons in its valence. And that gives a total of sulfur of 8 in each valence as well. And this is an example of a double bond. Thank you. In this tutorial, we're going to be working with the polyatomic ion cyanide. And in cyanide, it is distinct because it has an extra electron, which is added, which is indicated by the symbol on the ion. And carbon has a valence of 4, while nitrogen has a valence of 5, plus the extra electron that is indicated, and that gives you a total of 10 electrons. And this is unique because you'll actually be requiring a triple bond, which is a sharing of 6 electrons all together, indicated 2 by each of the slash marks. And that will satisfy each atom because they each now have 8 in valence. You have 6 in the middle and 2 on the outside, which adds to be 8. Thank you kindly.
Now we have to do this.
Oh yeah, and since it's a polyatomic ion, you have to indicate that in brackets with the negative symbol on the outside. Thank you.
Okay, resonance structures is when one or more LED can be drawn. With SO3, you have 1 S and 2 O's, 3 O's. And you have 2, 4, 6, so you take 24, subtract 6, and you have 18. So then you draw the 18 around the O's, and now all of the oxygens are happy, but your sulfur is not. So you need to change one of the oxygens to a double bond. But with this, any of them can be valid. You can draw it on top or the bottom or the side. So what you have to do is you have to draw all 3 possibilities, and then you draw a double arrow and box it in. And that is your Renaissance structures.